Find the area, centroid, inertia, and volume of the parabola, which is y is equal to x squared, and the horizontal line, which is y is equal to 4.
Let's find the area between the parabola and the line from where they intersect, which our y is equal to x squared, and it is a parabola opening upward. So upward, and our y is equal to 4, which is, this is a horizontal line. So now we have to find the point of intersection, but first set the equation equal to find the limits of integration. So our y is equal to x squared, and the value of our y is equal to 4. So this will become now 4 is equal to x squared, and x, this will become now the square root of 4. Then the square root of 4 is equal to x plus positive and negative 2. So that's why it gives us this value of x, the negative 2 and the positive 2. So here is our 4. So with this equation is a parabola which is opening upward. That's why our graph will be look like this. And we have to shade this area. So our formula for finding the area, the area will be the integral of limits, which is ab f of x minus g of x. So our f of x will be, so let's write our f of x. So our f of x is equal to 4, and our g of x is equal to x squared. So now let's plug or substitute this value to our formula. But wait, our a is equal to negative 2, and our b is equal to positive 2. So this get from answering this intersection, and now substitute this value in our formula. So area, what is our a? It's equal to negative 2. Our b is 2, and our f of x is equal to 4 minus the g of x, which is equal to x squared. Now let's integrate this, which the integral of the constant will be having a variable, right? So this will become 4x minus, so we have to use the power rule for this x squared. So we have to add plus 1 over 3, right? So x cubed over 3. And now, so substitute the value of limits in this equation. So area becomes 4 multiplied by 2 minus 2 cube over 3 minus 4 multiplied by negative 2. So substitute the a limits, our a limit minus negative 2 cube over 3. So let's delete this first. So if we are going to plug this area in calculator, this can give us 16 over 3, and this one can give us also positive 16 over 3, and 16 over 3 plus 16 over 3, which is equal to 32 over 3 square units. So this will become now our final answer. In between. So to find the centroid of a planar region, we have to use these formulas. So for solving our x, which is equal to 1 over a integral of limits a b x bracket f of x minus g of x close bracket dx, and for our y is equal to 1 over 2a bracket f of x squared minus g of x squared close bracket dx. So these are the important formulas to solve this centroid. So our answer of area in previous problem, so our A is equal to 32 over 3. So now let's plug the value of this. So we know that our f of x, which is 4, right? And our g of x is x squared. So substitute the value of that in our formulas for finding the x. So x 1 over 32 over 3. So our a is the same limit. So negative 2, positive 2, x, and our f of x, which is equal to 4 minus the g of x, which is x squared, close bracket dx. So since this is an add functions over a symmetric interval, so which is the value of dx is equal to 0. So no matter how we solve this problem, because it multiplied in our dx, which is equal to 0, so the value of this x is equal to 0. Let's erase this. So our x is equal to 0. Then let's solve out for our y centroid. So y 1 over 2, the value of area, which is 32 over 3, bracket our f of x, which is 4 squared, minus the g of x, which is x squared, raised to 2, close bracket dx. So let's solve this part first to avoid redundance. So 4 raised to 4, which is 16. So x squared raised to 2, which can give us x raised to 4 dx. And now let's integrate this, which is negative to 2. So 16 will become now 16x minus, use this power rule for this x raised to 4. So this will become now x raised to 5 over 5 dx. Then substitute the value of limits in this problem. So let's rewrite this So 1 over 2, 32 over 3, multiplied by this. So 16, the value of limits, which is 2 minus, 2 raised to 5 over 5 minus, let's use bracket for this, 16 negative 2 minus negative 2 raised to 5 over 5. So in calculator, the value for this is equal to 3 over 64. So multiplied, so solving this or plugging this in calculator, that this gives us the answer of 96 over 5. So this is 288 over 320. So the lowest term for that is 9 over 10, and the decimal, or let's turn this into decimal, can give us 0.9. So the value of our y is equal to 0.9, or 9 over 10. So let's put it here. The value for our x is equal to 0, and our y is equal to 0.9. So this is the centroid of the shaded region.